Hello everyone, this is Dr. Captain K. Sujata, Professor of Mathematics, St. Joseph's College for Women, Autonomous, Visakhapatnam. In this session, I am going to discuss overall explanation of unit in the examination point of view, Unit 5. Learning outcomes. After successful completion of this lesson, the student will be able to solve linear differential equation, solve the linear equation of second order with variable coefficients by using change of dependent variable when the part of complementary function is given, is known. Solve the linear equation of second order with variable coefficients by using variation of parameters as well as the Cauchy-Euler equation, and last session we have discussed this. Then coming to the next one, linear equation of second equation, linear differential equation of order n. This is a linear differential equation of order n. Coming to the next one, this is the linear differential equation of second order with variable coefficients, right? So here P, Q and R are the real valued functions of x defined on an interval I. Now Lesender's differential equation also, here Lesender's form also we going to discuss in this lesson. Next, this is next one, the linear equation of second order with variable coefficient can be solved by the following methods. Change of dependent variable when the part of complementary function is known. This is the first method. And next one, variation of parameters. Now coming to the method 1, the change of dependent variable when part of complementary function is known. Working rule to solve d square y by dx square plus p into dy by dx plus qy is equal to. Suppose the differential equation given in this form. So first what we have to do, reduce the given equation to the standard form as like this, and either the part of complementary function is given or it can be found by inspection method. Let it be y is equal to u. Now after that, let take y is equal to uv be the general equation, general solution of equation 1 where v is equal to f of x. Then on differentiating this one, we will get these two equations. 2 times twice we have to differentiate, we'll get those two equations. After that, substituting these equation in equation 1, we'll get this is a form. Now in this P1 is this one. Taking dv by dx is equal to v, d square v by dx square is equal to dv by dx, and we will get the, so equation 2 becomes like this. Now finally we have to replace capital V by dv by dx. On integrating we will get v, small v. Then the required solution is y is equal to uv. Now working rule by the inspection method to find the complementary function in terms of the inspection method. So suppose if this equation will be satisfied, then the CF is the complementary function is y is equal to x. If this is satisfied, then y is equal to x square. If this is satisfied, then y is equal to e power x. This is satisfied, y is equal to e power minus x. Now coming to the problems. So already I discussed in the last session, just examination point of view, I'm going to revise all the methods in this lesson, in this session. So this is the differential equation we have to solve. So see, first of all, whether the complementary function is known, then directly you can solve, you can find out the auxiliary equation. Then after getting auxiliary equation, see, if the complementary function is known, then find out the what we, after getting the complementary function, what we have to find out this complementary function, then directly you can find out general solution. Suppose use the inspection method, then find out the complementary function, right? So after getting the complementary function, then write down the general solution. After getting the general solution, then write down the in the form of the linear form. Then after getting the linear form, then dv by dx is equal to capital V. Then write down in the form of the equation 2. This is a linear equation in v and x. Then compare this with the linear equation. Then find out the integrating factor. After getting the integrating factor, then general solution. Right, after getting general solution, then find out v. So how to get the v? Have to integrate it. We'll get the v. Then again put it in the general solution. Y is equal to uv. Right. This is another form of the differential equation. Here the complementary function, again it is here not given. So using the inspection method, find out the complementary function. So this is satisfied in this. So this is a complementary function. Right. So after get the general solution, for getting the general solution, we have to write down y is equal to uv, then differentiate twice and substitute in the equation 1. So we'll get this is a pattern. Then after that, compare this with the linear equation. We find out the integrating factor, then write down the general solution. Right, this is a general solution. Right, coming to the method 2, variation of parameters. So variation of parameters, in this case, the given equation is not in the standard form, reduce into the standard form. Find the solution of this. Then let the particular integral of equation 1 is yp is equal to au plus bv, where a and b are functions of x. Right, then after that write down u into dy by dx minus v into dy by dA. After writing this, then find out a and b using these two formulas, then write down the general solution. Right, so in order to solve the linear equation of second order, so second order, this is a differential equation, linear equation second order, we have to follow the following methods. Suppose if the complementary function is given, then as usual, you can follow the find out the general, try to the general solution. Suppose if it is not given, then using the inspection method, find out the complementary function. If the method is mentioned in the given problem, then only apply the method of variation of parameters. That is this method. So these are the problems on variation of parameters. So find out A and B using the given formula, then substitute in YP, particular integral, then write down the general solution. So this is the second equation of the method of variation of parameters, dividing x minus, first of all converted to the standard form, then write down PQ and R, then use the inspection method, find out the complementary function. For both the cases, find using the inspection method, find out the complementary function, then write down, use the variation of parameters, then write down a and b particular integral, write down, and where a and b are the functions of x. Here u is equal to e power x, v is equal to x, and then you, by the method of variation of a parameter, write down the pattern, then find out a and b using the given particular formula, then write down the general solution. Next, coming to the Cauchy-Euler equation. This is a Cauchy-Euler equation. Write down the form of the Cauchy forms, then do the sums. Now, for applying the in the Cauchy form, we need auxiliary equation. Auxiliary equation, different patterns are there. Suppose the given equation, the roots will be maybe distinct or real, maybe real and equal, or maybe real and complex roots. So to get the general solution of the f of d into y is equal to 0, there is a general solution. The using the general solution, then write down the step 1. After that, this. So if the roots are suppose the real and distinct roots, then the complementary function should be right like this. Y is equal to c1 into e power m1x plus e2 into e power m2x plus e3 into e power m3x like this. Suppose the roots, two real roots, two, suppose f of m is equal to 0, 0 has two equal roots and other are distinct roots, then write down the complementary function general solution as y is equal to like this. Suppose the three equal roots and the remaining distinct roots, we should write like this. Suppose the roots are imaginary, so we have to write the complementary function general solution as like this. Suppose the four roots are complement roots, remaining are the real roots, we should write like this, right? So suppose imagine irrational roots. Suppose if we get the irrational roots, then we have to write some irrational roots and some real roots, we have to write like this using the hyperbolic function, right? So see the problems, Cauchy equation, convert the Cauchy form, we will get the complementary function. So auxiliary equation, after getting the auxiliary equation, write down the complementary function yc, whether they are, observe that whether they are real or distinct or equal or imaginary or imaginary roots or irrational roots, Like that, according to that, use the formula, then find out YC, then find out the YP using the particular solution. Different patterns are there. We have discussed in the previous lessons. Because according to that, simplify this. If it is a u power z, directly you can substitute e power az, then a value is and substitute in this, we will get the value of the, we'll get yp, then write down the general solution. Now, this is another type. First of all, write down the form using the Cauchy-Euler equation, Euler form. Then we will get the, using this, we will get the auxiliary equation. So, write down the roots. Here we got the imaginary roots. Then this is a YC. Then write down YP. So, this is in the form of YP. It is a product of the two functional values. One is exponential function, another one is a trigonometric form. So if it is exponential function in this a, e power 2z is there. So z coefficient is a is 2 here. So we have to add here to the theta, right? If suppose the function is like this, we have to do like this, right? Then after that, using the, then apply the formula for this. 1 by, this is in the form of 1 by theta square plus 1 into sine theta. So in the form of the here, this is in the form of, in terms of the trigonometric function, this one format is there. If is any cos theta, sine theta, from theta square, we have to replace the by the theta square by minus 1. Then after that, you have to simplify this minus 1. Then after that, theta is a differential operator. According to that, you have to simplify this. This is another type, convert into the Cauchy form. Then here the two equal roots, one is an independent root. To that we should write like this. So this is a Legendre's equation. This is a Legendre's format form. So using the Legendre form, you can do the sums. So these are the problems in Legendre's. So apply the Legendre format, and then we will get the auxiliary equation from this. After getting the auxiliary equation, then write down the complementary function. So this is a complementary function, then write down the particular integral. So from here and from this step, we can follow the previous method only. The general solution is y is equal yc plus yp. Right, here also this is another type of the Legendre's form, Legendre equation. So convert into the Legendre form, then after that write down the auxiliary equation, write down the roots. These are the two distinct real roots. Then this is the format. Then after getting the yc, then go to the yp. This is the format. Then use the formula of the yp. Different types are there, we have explained in the previous chapter, previous lesson. According to that, we have to expand this. So replace finally in this method here, replace theta by 1, theta by 0, we will get this. Then write down the general solution. Right. So with this, I'm going to conclude this lesson or this session. In this session, we have discussed overall explanation of the unit in the examination point of view of unit 5, linear differential equation of order n, working rule to find the general solution of d square y by dx square plus p into dy by dx plus qy is equal to r by the method of variation of parameters. Solve the linear equation by using Cauchy-Euler equation. Solve the differential equation by using the Legendre's equation. Thank you.